in this unit if you haven't caught on to that. Okay. Modeling with functions is what we're looking at. When we talk about modeling with functions, basically we're looking at some formulas. Okay. Some of these formulas which you know or should know.
Pi r squared.
Or some of these formulas which you know may be new to you. In some situations they're provided formulas. In some situations we're creating the formula. We're composing it. So, as we look at example 1, they're asking us to write the area A of a circle as a function of its, and then there's 3 parts here. Now, this is one I always say you should know. So if you're going to bulk and say, nope, I don't know it.
Facts.
Basic area of a circle. What's the formula that I would like you to know, that any math teacher would like you to know?
Basic area?
Yeah, area of a circle.
It's not, is it pi? No, pi r squared. Is it? Yeah, that's what I thought. Okay. Yeah!
Yeah.
Don't doubt me. I'm going to doubt you again.
Okay, so just as a math student, as a human being, area of a circle, pi r squared. Okay? Now, I'm trying. I guess there's Google, right?
There is always Google.
Or Siri, or Alexa, or whoever. Okay.
Facts. Back it up.
Now, part A, ask us to write the area formula as a function of its radius. What they're asking for here is the area formula in terms of r. But what's the area formula you just gave me?
Pi r squared.
So right here, there's nothing to be done for part A.
Oh, yeah.
Okay? Part A is writing the area in terms of r. So where you have to know the r value to find the area. That's what I mean, you know, r is what you're going to input here.
Oh.
I thought it was asking like how
I think
you
I got
find
the next
radius, like set up the equation equal to r.
No.
That's what I thought.
So that would be solving for r in terms of A. Okay.
Sure.
Here, this is writing the area A in terms of r. Now, or as a function of r. B, we're going to write the area formula as a function of its diameter, which means instead of my area formula being in terms of r, my area formula is now going to be in terms of d, or in other words, diameter. Okay? You're going to jump right in?
A equals pi d.
No,
No.
Ah.
because 4 squared equals 16, but the diameter would be 8. Like you can't just multiply it by 2 because not everything squared is.
Okay, so then pi r squared divided by 2?
No.
No.
Okay. It's that r squared in there means we can't just divide by 2 like you want to. Start with there's currently an r in this formula.
Yes.
What is the connection you know between r and d?
2r equals d.
Agreed?
Yeah. So pi 2r.
Oh, yes. So
2r equals d.
Oh, is that
Now. With that in mind, okay, we know 2 times the radius is equal to the diameter. That's basic knowledge.
Yeah.
So what is then the diameter equal to? If you solve this, not diameter, what is the radius equal to? We could rewrite this and say radius is
Half the diameter.
half the diameter, yes? Radius is d divided by 2.
it would be
D divided by
a equals pi d divided by 2 squared.
Okay, so he's seeing where we're going here. We're going to take the r from the last formula, and we're going to fill it in with d over 2. So pi times, instead of r squared, d over 2 squared. Now, I am asking that we clean this up a little bit.
I can.
Okay. What is d over 2 quantity squared?
D over 2 squared.
So what is d when you square it?
D squared.
D squared. What is 2 when you square it?
4.
4. So I can rewrite this as pi times d squared over 4, correct?
I mean, apparently.
In other words, I'm doing the math, I'm cleaning it up. Now, if we kind of put this in the form of A is pi, it's the number times radius squared. I'm going to rewrite this one and pi, and I'm going to take this 4 over here with it. Okay, because this is a dividing by 4, yes? In other words, I mean, you could put this all together and say pi times d squared all divided by 4. Or a more common way to write this would be pi divided by 4 times d squared.
Well, yeah.
It is. It is. It's all the same.
Why does it matter?
It's just kind of best ways to clean it up. Okay? There are multiple ways you could write this and it still be correct. Okay? I'm not saying that this is the only way to write it.
Let's say I just do the A equals pi d divided by 2 squared. What?
Okay, let's look at C now. C is asking us to write the area of a circle, but this time in terms of its circumference. What do you know about the circumference of a circle?
It's the circumference.
Does that involve 4/3?
No.
Is that not?
Is it something we're supposed to know?
Circumference is the area around a circle, so it'd just be like it's like the length around a circle, like it's
Distance around a circle.
It's like its perimeter.
Diameter
It is.
squared. I don't know. I'm not gonna lie.
Uh,
Diameter times 3/3.
3/3.
I don't. I have no clue.
Okay. Usually these are the formulas you give me instead of area, because area is pi r squared. What I normally get instead of pi r
2
squared,
pi r.
or
Yeah.
what's the other version of 2 pi r?
2 pi r. 2r pi.
No.
what?
I don't know.
Okay, circumference.
Oh,
Guys,
pi d.
stick it in that file in your head somewhere. Circumference, 2 pi r or pi d. They're equivalent. Okay, it's distance around a circle. These are formulas that I'm always going to say you should know. Okay.
The goal is to set.
Now, hold on. I can't do anything until we know what the circumference formula is. I can't even begin this problem until we know what circumference is. I got to get you there. Okay, now, we're trying to write this area formula, yes? If I go back and use area equals pi times r squared, I would say take this and solve it for r. So if we take this and solve it for r, what is r going to be equivalent to?
Or C over 2 pi.
C over 2 pi. Agreed?
Yeah.
So now, if r is equal to c over 2 pi, take your area formula, which is area equals pi times r squared. What are we putting in place of r? C over 2 pi squared. Okay? So pi, and actually I'm going to write that pi as a fraction. What is pi as a fraction? It's going to be pi over 1. And I'm doing this leading up to my next step. Square that fraction.
C squared.
C squared over 4 pi squared. Right? When you square a fraction, you're multiplying top by itself and bottom by itself, right? Now, I had us do this for a reason. Something can cancel.
The pi. 1 pi of them.
1 pi on top can cancel with 1 pi on bottom. Okay? And then when I clean this up, I can say area is equal to
C squared over 4 pi.
circumference squared divided by 4 pi. Okay? We have just written the area of a circle formula in 3 different ways. Okay? Part A, if you know your radius, you can use this to find your area. Part B, if you know your diameter, you can use this to find your area. Part C, if you know your circumference, you can use this to find your area. Now, obviously you guys know, if I give you the diameter, most of you are just going to take half the diameter and then plug it into our normal formula.
Yeah.
I get it, it works. But these are options, and sometimes they're necessary options depending on what you're doing within a problem. Okay? Okay. Moving on to example 2 if we're ready.
Born and raised.
I'm not ready.
All right, Paxton. Well, it's not about
Okay.
you, okay?
I'm not looking for, I don't think I'm looking for the male opinion today.
The world is not revolving
Women,
around
are you
Paxton.
ready?
Ready, Paxton?
Oh,
Females.
Men don't have to do it? Okay.
Oh, we don't have to do it. Let's
No,
go.
gentlemen, cool it, seriously. Example 2. A square of side x inches is cut out of each corner of an 8-inch by 15-inch piece of cardboard, and the sides are folded up to form an open-top box. Write the volume of the box as a function of x. Okay,
Why do we do a lot of circle stuff just to talk about square?
it's all about formulas today. It's all about formulas. So we talked about circles. Now we're going to talk about a box. Now, it's asking us to write the volume of the box as a function of x. Let's just start with volume. Volume of a box.
Length times width times height.
Agreed?
What did you say?
Length times width times height.
Said very quickly.
I heard that time my time.
It was length times width times height is the volume of a rectangular box, right?
C.
Now, they want this done in terms of x. So I don't want L, I don't want W, I don't want H. But this is our starting point. So, we're going to draw a picture. Or let me rephrase that. I'm going to draw a picture. Okay? You do you. A square of side x inches is cut out of each corner of an 18 by 15 inch piece of cardboard. So I'm going to draw there is my 8-inch by 15-inch piece of cardboard. It is 15 inches across the top, 18 inches on the side. Okay? Then, a square of side x inches is cut out of each corner. So, are you with me?
So far.
A square of side x inches is cut out of each corner. So right here in this top corner, there's a square x by x cut out. In this other corner, there's a square of x by x. X by x. And x by x cut out. Okay? So it's the idea that those corners are cut out, and then the sides are folded up to form an open top box. So you cut these corners out, and you're going to fold up the sides that remain, and that forms our box.
Sure.
The length of this rectangular piece of cardboard is 15 inches.
No, it's 15 minus 2x.
Thoughts on going to be the length of this open top box? Do you guys see it?
Not really. Oh wait, yeah, I see it. I see it.
Next way.
I see it now. I see it now. Okay.
Guys, cool it. Okay, the idea is up top, end to end is 15. I'm going to take out this corner. Okay, this corner is going to be gone. I'm going to take out this corner. They're going to be gone. What remains here for the length? It's the 15. Take away the 2x. So my length is going to be 15 minus 2x. Okay. What about what we would consider the width of the box?
8 minus 2x.
Okay. The width of this piece of cardboard was 8 inches, but we're going to take out one corner and the other corner, what width remains?
8 minus 2x.
So we're gonna have a width, 8 minus 2x.
So, how does one find the height in this situation?
So the next question is the height of this box. So we had this piece of cardboard.
X.
We cut out the corners. We're gonna fold these flaps up. What is the height of these flaps I'm folding up?
Whatever that x is, yeah.
See right here, you'd fold along that green dotted line, you'd fold this flap up. What's the height right there?
Whatever side that x is. Right?
And that is x.
Let's go.
So you're gonna have a height of x. So it asks for a volume formula. For the length, we're using.
15 minus 2x.
For the width, we're using.
8 minus 2x.
And for the height, we're using
X.
x. Now,
Are we gonna have to flip? Or we just distribute?
in my notes, I don't have it multiplied out. I have that as my final answer.
Hey, well, we're good
Oh,
with that.
we're good with that.
We're good with that.
Answer.
Well,
No,
it's already,
it's
it's already.
Can't change it,
It's already
no take back.
Sorry,
And here's what I'm going to say, guys. Okay, here's what I'm going to say. Could we multiply this out if we had to?
If we had.
Okay, we can, right? There is a multiplied answer where you would foil the two pieces and then distribute the exit. And that is a possibility. Okay? I don't think, from what I'm trying to remember what the homework all entails, but I don't think it's necessarily multiplied out. Okay? And I'm just trying to give you guys examples to be starting to think about, okay, what, how can we do some of these formulas here? Okay. Questions on that one?
Negative.
Okay. Let's talk about Mark.
Mark. Good.
Mark received an 8.5% salary increase. His salary after the raise was $36,890. What was his salary before the raise?
One,
32,000.
you just multiply 36,890 by 0.0915. Or not 09, just 915.
Where are you getting the 915?
Take 8.5% away from 100. 91.5%.
This man's too smart for me.
I don't think that works.
I think it would. I think it works.
I think it will.
32,550.
Yeah, it doesn't work. That's what I thought.
What?
Okay. So, and here's what makes this problem a little bit more difficult. They didn't give us the salary before the raise, did they?
Mm-hmm.
They gave us the salary after the raise is already added on. So I'm going to have us think about an equation here in that okay, I know the total salary is $36,890, yes? How did we get that $36,890? You added some, don't get specific here, just you added a raise onto what?
His previous salary.
His previous salary. Okay, so I'm going to use X as the previous salary. Okay, or original salary, I'll say original. Now, if X is the original salary, you have his original salary plus, so X plus some raise. How do you find the raise if you do know the original salary?
You just multiply the original salary by the rate.
multiply the original salary, so the original salary being X, by the raise. What is our raise?
8.5%.
8.5%. What do we know about 8.5%? It's equivalent to 0.085. So what I'm suggesting we do is that we're going to take 0.085, multiply it by his original salary. That's going to give us the raise. So are you with me here? That this is
That was close.
original salary plus, this represents his raise. Okay, original salary being X, the raise being 8.5% of his original salary. Now, can you add those pieces on the left? What is X plus 0.085X?
1.085x.
Okay, there's an invisible 1 here, yes. So 1.085x, and that is equal to the 36,890. And then to solve this, you're going to
About 1.085.
divide by 1.085. Your calculator will do the math for you, right? What do you get when you divide by 1.085? 34,000? Okay, and this would be $34,000. Okay, so his salary before the raise is $34,000. If you multiply that by 0.085 and add it back together, or multiply by 1.085, you're going to get his new salary of $36,890. Now, real quick, while we're on this problem and our brains are kind of in this mode here, the second part. They don't give specifics, just what is the general cost of an item after a 45% decrease.
X.
You're going to jump right in, aren't you?
No, I'm not going to give you the answer. What else?
Okay, go ahead.
If X is the original cost, it's 0.55x.
And why would it be 0.55x?
Because that's the total, because they lost 45%, so all you have left is 55%
Okay.
of the original cost.
So 45% decrease means we're going to subtract off what percent?
45.
45%. So it's like saying, okay, the original item minus 45%. So basically what we're looking at here is 100% minus 45%. And what is 100% minus 45%? That is 55%. Or in other words, 0.55 times X. This is a good shortcut to use. If there's a 45% decrease, you can do 0.45 times the item and then subtract it from the original cost. Or do the subtraction ahead and just do one multiplication. Okay, you can do the same thing. If an item is 10% off, how much do you have to pay?
90%.
90%. So do 90% of the original cost.
I would say we're done. No.
Okay, tomorrow we will finish notes. You could start working on homework some. I hate to say it, but we should have work time tomorrow, but who knows?
Guys,